Okay, we are back. We are continuing, and now we are doing question B. What does question B say? Show that AB is equal to 59.3. Correct to one decimal place. So we need to find AB. We have to find AB, and we need to show that it is 59.3. Now, here is AB, here. And it's a part of a triangle. The triangle ABC. Now, which is this one, obviously everybody can see it. Now look here. This is easy. You're looking for a side and you have a non-right angled triangle. I've taught this in Trig section 3, but I'm just going to say it again right now. When you have a non-right angled triangle, you only have two possible methods to solve for missing sides. One is the sine rule, the other one is the cosine rule. Now, these two formulas are given to you in the front of your paper. So you don't have to remember nothing. You just have to know that this is the cosine rule because it has cos, and then the other one is the sine rule because obviously it has sine in it. So now, when do I use the cosine rule? When do I use the sine rule? The cosine rule is used in only two situations. Obviously, it will be a non-right angle triangle, yes, but then it will either have an included angle or you have a non-right angle triangle and you are given all three sides. And then they ask for an angle. Are you hearing me? So we said, what are the two things where you use the cosine? Any other case, you have to use the sine rule. For cosine rule, you have to use it when you have, number one, included angle, and then number two, I'm going to show you an included angle. Obviously, I'm going to show you. Then number two, when you are given all three sides and they ask for an angle. For these situations, you have to use the cosine rule. It's a must. Now you say to me, what is an included angle? You're going to get a non-right angle triangle, and then you are going to be given, I have highlighted it in yellow. Maybe let me highlight it in another color with you right now. You will get one side like this. I'm highlighting in blue. Can you see my highlighter moving? You get this side, then you get this other side, then you are going to get the angle between them. So if you have a right angle, if you have a triangle, sorry, and I tell you that this side over here is 10, then I tell you the other side, which is also coming to the same vertex, is maybe 9. Then I tell you this angle is 30 degrees. You have an included angle because you know the two sides that make the angle, and you know the angle between those two things. So it's like you know the two sides that are coming in, and you know the angle between them. We call that an included angle. It's an angle sitting between two sides that you know. If you have a situation like that, that is cosine rule. You have to. But let's say you are told that this is 11 and you're not told this one. You can't use the cosine rule here because you don't have an included angle. Because for the angle we don't know the other side that is coming in to make it. What we know is we know the two sides that are coming to this angle here. I can show it to you here in pink, this angle. But we don't know the angle. So we don't have an included angle. So this has to be a sine rule question because it does not meet the conditions for cosine. Cosine has to be an included angle or you should know all three sides. So if you look at this one, it's a non-right angle triangle. So that means don't you think of Pythagoras. You will be lost. You will be in the bush. Don't think of Sokotoa. Those are for right angle triangles. They are gone. They are not here right now. So I'm going to use either the sine rule or the cosine rule. Now, what do I check? The conditions for cosine. If the conditions of cosine are not there, then obviously it now becomes the sine rule, and I'll show you how to use it. But here we've seen, let's see, do I have an included angle? Oh, yes, I do. I know 65, which is one side coming in. I know 95, which is the other side coming in. And I know the angle between them, which is 38. So obviously, this is the cosine rule. Now, let's go to the front of the paper and let's see the cosine rule now. Let's see what the cosine rule says. Let's go to the front of the paper. Okay? Now, here's the front of the paper. Which one is the cosine rule? Let's go down a bit. The cosine rule, I put it for you here. Okay? Here, let me put it. This is section 3. I had written it. I'm going to write it again. This is section 3. These are formulas from the section which we are doing. The section of non-right-angled triangles. Are you hearing me? This is the section for that. Non-right-angled triangles. These are the things we use. If we're asked for area, we're going to use this. And then if we're asked, then we can have this which has sine. So it's obviously the sine rule. Then this one at the bottom which has cos here. So it is obviously the cosine rule. Okay, cos is cosine. Cosine and cos is the same thing. Cos is the shortcut to say cosine. So this is the cos rule or the cosine rule. What does it say? A squared is equal to b squared plus c squared minus 2bc cos a. So let's go and do it, and let's put it. We should be able to put it. Let me take it down. Let's go to where we were. Here it is. We are going to say, you put it with a pencil first, the cosine rule. You say a squared, okay, you're going to use the cosine rule for this question, which says a squared is equal to b squared plus c squared, which are the other two sides. B and c are the other. You want a side, this side. So it is equal to the other two sides, b squared plus c squared minus 2 of the same guys, b and c, but they're no longer squared. Then you now say cos capital A, which is the angle between them, which is the angle at A. So now the thing of it is, you can change this cosine, you can change the letters for them to suit the question you are doing. You don't have to use it in the state it is in. You're just going to change the symbol, but then this is the rule. But we are going to make it fit our triangle. This is not for every single triangle, obviously, because it depends what the side you're looking for. So now what you do is you're going to put the cosine rule. You've identified, point number 1 is to identify the rule. I've told you the reasons, and now you know how to identify. And you have identified that this is a cosine rule question, and you have put your cosine rule now. Now you have to make it suit the problem. So what you do is you're going to label your triangle. Triangles are labeled, guys. If you go now, what you do is this corner is called corner A. If you go opposite it, you're going to go to side small a. So this is side small a. This is corner B. If you go opposite it, you go to side small b. This is corner C. If you go opposite it, you go to side small c. So now I have labeled my triangle. Now which side am I looking for? I am looking for side C. This is the one which I'm looking for. The missing one. So what do you now write? You don't write it as A. Our version is actually C squared is equal to the other two. The other two are obviously A and B. So you're looking for C, so it's the C squared. This is equal to A squared plus B squared. Okay, first you write it as squared. Then you say minus. Remember, 2 of what? Of these guys you put, but they are no longer squared. Minus 2ab. Then cos of this letter now. Cos of C. That's what you do. So now let's go and write that. So we can say C squared is equal to A squared plus B squared minus 2ab. Then cos C. Now what do you do now? You're going to first find C squared. Let's find C squared, class. What is my A? A is 95, so it's going to be 95 squared. Don't you leave the squared. If you leave it, I don't know you. Plus B squared. What is my B? 65. Say 65 squared minus. Now, every time you say minus and a lot of things come, open a bracket and put the things. So it's now going to be 2 times, what's my A? 95. Times, what's my B? 65. Times cos of big C, which is the angle at C, and that is 38 degrees. Now let's punch that in the calculator. I'm going to punch it. 95 squared plus 65 squared minus, open bracket, 2 times 95 times 65 times cos 38, close bracket. Okay, what is this going to be now? This is 3,000, so I can say C squared is equal to 3,518.067, blah, blah, blah. What is C? Is the square root of that, of 3,518.067. Okay, then I'm going to say square root of the answer. Now, what do I get when I say square root of the answer? I get 59.313, blah, blah, blah. So I'm going to say C, okay, C is equal to 59 59.3. This is going to be my C. Is it the same one as the one they have? Yes. Am I correct? Obviously. You're done. You're correct. Now we go to part C, which we're going to do in the next video. Goodbye for now.